Welcome to Atomic City, a place where peace never lasts. Two rival gangs rule the streets, the Alkalis and the Halogens. The Alkalis are burned with an extra electron they don't want. The Halogens prowl hungrily, desperate to snatch one more. It's an endless turf war. Both sides are desperate to stabilise their gangs, but the battles only plunge the city deeper into chaos. What they don't yet realise is that the key to peace isn't more fighting, it's a deal. Deal that will transform them into something new, powerful ions, and unite them into an unstoppable force, the giant Ionic lattice. Welcome to Atomic City, a place where everyone's chasing the same goal, stability. But trouble is brewing, the peace talks are about to begin. On one side we've got the Alkali gang. They got one extra electron they don't want. It's like carrying around a spare wheel that doesn't fit in the car. On the other side, the Halogen crew, prowling the streets desperate for just one more electron to finish the set. And when these two unstable groups meet, chaos clashes erupt across Atomic City, and the place is buzzing with instability. That's when King Neon, ruler of the stable outer shell royals, calls them to the table. King Neon raises his hand at enough storms and struggles. He declares, it's time to trade, to make peace, to find stability with a full outer shell. The gangs look at each other. One has an extra electron to give, the other is desperate to take it, and a deal might just work. And so, under King Neon's watchful eye, the Alkali gang and Halogen crew sit down together. Message is clear. Stability is the prize. The Alkali gang hands over their unwanted electron to the Halogen crew, grabs it instantly. Finding their shell is complete, the fighting stops. Both sides are now satisfied. The Alkali gang is lighter, stable with its new full shell. The Halogen crew is fuller, stable with 8 in its outer shell. And King Neon smiles proudly, peace has been restored. From this day forward, the gangs no longer fight. They've joined forces, rebranding themselves as one powerful organisation, the giant Ionic lattice, a network held tightly together not by magnetism but by the invisible pull of opposite charges, electrostatic attraction. Here's how the treaty works in Atomic City. On the left we've got lithium from Alkali, it's unstable with just one lonely electron in its outer shell. On the right, fluorine from Halogen Ghetto, reactive with 7, desperate for one more to feel complete. Look closely at lithium's outer shell. That single extra electron is a burden, makes lithium unstable, while fluorine's nearly full shell is screaming out for just one more. The stage is set for a deal. Lithium's electron starts to move, edging away from Alkali Heights, crossing the city streets towards Halogen Ghetto. Lithium is ready to give up. Fluorine is ready to take it. And just like that, lithium lets go. Now lithium is stable with 2 electrons in its inner shell, while fluorine finally has the full 8 it was craving. This trade creates a perfect balance. Lithium becomes a positive ion, a cation, because it's lost an electron. Fluorine becomes a negative ion, an anion, because it's gained one. And here's the key. Opposite charges attract, just like magnets snap together, but this time it's not magnetism, it's their charges pulling them in. The positive lithium ion and the negative fluoride ion are locked tightly together by electrostatic forces. This ionic bonding in action. Alkali metals like lithium always give away electrons. Halogens like fluorine always grab them. Both get what they want, a stable outer shell. And in the process they join the powerful Ionic lattice, structure held together by the strongest forces in Atomic City. Now let's break down the science behind the story. Atoms can come together and exchange electrons. Here we see lithium on the left with just one lonely electron in its outer shell. Fluorine on the right with 7 electrons desperate to complete its shell. Lithium decides it doesn't want that spare electron anymore. Fluorine is more than happy to take it. We can describe this as lithium gives and fluorine grabs. This process is called ionic bonding. Lithium has lost 1 electron, fluorine has gained 1 electron. Both now reach stability. Lithium has lost its electron and becomes a positive ion. Li+1. Fluorine has gained an electron and becomes a negative ion. F-1. So lithium is now a cation, positively charged, while fluorine is an anion, negatively charged. With both ions stable, each has a full outer shell. They're more stable as ions than they are as lonely atoms. And here's the key: opposite charges attract. Lithium and fluorine are pulled together by strong electrostatic forces. This is shown in the dot and cross diagram. Lithium plus, fluorine minus locked together. Notice how the transferred electron is drawn as a dot, showing where it came from originally. This also lets us write an ionic formula. Lithium fluoride. We put square brackets around ions with their charges shown outside. Lithium is 1 plus, fluorine is 1 minus. And together they balance perfectly, a stable ionic compound. Lithium fluoride, with lithium as a positive ion, hence the cat, and with fluoride as a negative ion, hence the crying onion or anion. Let's try a slightly trickier example: magnesium bonding with chlorine. Magnesium starts with 2 electrons in its outer shell. Chlorine has 7, needing just 1 more. Magnesium loses 2 electrons, 1 to each chlorine. Each chlorine grabs an electron, fills its shell. Now magnesium has lost both electrons, becoming Mg2+. Each chlorine has gained an electron, becoming Cl-1. 2 chlorines are needed to balance magnesium. The dot and cross diagram shows this clearly. Magnesium in the middle, 2 chlorines either side, each with full shell. The formula is MgCl2, 1 magnesium ion for every 2 chloride ions held together by electrostatic attraction. So as we can see, magnesium is a positive cation and chlorine is a negative anion. Now let's zoom out and look at ionic bonding as a whole. When atoms swap electrons, they form charged ions that stick together. For example, sodium and chlorine. Sodium loses 1, chlorine gains 1. Sodium becomes Na+, a cation. Chlorine becomes Cl-, an anion. Together, Na+ and Cl- form sodium chloride, salt. The key here, ionic bond, is simply the strong electrostatic attraction between oppositely charged ions. These forces pull equally in all directions, creating a giant lattice structure. Just like magnets, opposite charges pull together, but here it's not magnetism, it's electrostatics. That's why Na+ and Cl- lock so tightly in place. Let's look closer at these giant ionic lattices. This is the giant ionic lattice for sodium chloride. Sodium ions and chloride ions are arranged in a repeating 3D structure. The ions are held together by strong electrostatic forces between positives and negatives. These forces pull in every direction, making the structure extremely strong. That's why ionic compounds have high melting and boiling points. Huge amounts of energy is needed to break those bonds. In solid form, the ions are fixed in place, so ionic compounds cannot conduct electricity. But when molten or dissolved in water, the ions are free to move, and then they can conduct electricity. Bonding strength depends on 2 things: ion charge and ion size. Here's lithium fluoride, lithium plus and fluoride minus. Because the ions are small, the attraction is strong, but since the charges are only 1 plus and 1 minus, force is limited. Compare that to magnesium chloride. Magnesium is 2 plus, each chloride is 1 minus. Magnesium chloride has a higher charge giving stronger electrostatic forces. That's why MgCl2 has a higher melting point than LiF. This slide sums up all the key material we covered in the video. On the left you can see the main ideas about ions, group trends and how ionic bonding works. On the right you've got the key properties of ionic compounds. And for those of you aiming higher, there's a special higher tier section too. Pause the video here, take the notes you need and make sure you've got everything written down clearly. Thank you for listening and well done for working through ion trouble in Atomic City.